We will now apply what we have been learning about exponential functions to banking and loaning applications. Suppose that we plan to borrow $10,000 in student loans for college. How much money do we pay back to the bank that loans us the money? Just $10,000? But what's the incentive for the bank to let us borrow that money? In other words, what's in it for them? Paying back the loan, we will need to pay back more than what we borrowed. This extra money paid back is called the interest. The amount of interest that we pay back depends on how much money we borrow and is given as a percentage. For our example, let's assume that we have to pay back an extra 6% for every year we borrow the money. This is called the annual interest rate because the 6% is owed every year. Notice that this means the amount of money we owe depends on how long we borrow it for as well. In other words, the amount of money we owe is a function of time, which we can write as P of t, where P is the amount owed, often called the principal, and t is the number of years the money is borrowed for. Now, the amount of money owed in the beginning is given by P of 0 equals 10,000, because in the beginning means 0 years have passed, t equals 0. Now, the amount we owe after 1 year is the original 10,000 plus 6%, or 0.06, times the 10,000 in interest. Notice here that we can factor out 10,000 and write this as 10,000 times 1 plus 0.06. In computing this, we get $10,600, which means that we paid $600 in interest in the first year. So how much do we owe after 2 years? The amount we owe after 2 years, P of 2, is the $10,600, what we owed after 1 year, plus 6% of the $10,600 in interest. Again, we can factor out the 10,600 to get 10,600 times 1 plus 0.06. But remember, P of 1, the 10,600, is 10,000 times 1 plus 0.06. So we can rewrite the right-hand side as 10,000 times 1 plus 0.06, which is P of 1, times another factor of 1 plus 0.06. This leaves us with P of 2 is 10,000 times 1 plus 0.06 squared, which comes to 11,236. Notice, we paid another $600 in interest on the original $10,000 we owed, and an extra $36, which was the interest on the first $600 of interest. So we were paying interest on the interest. This interest earned on previous interest is called compound interest. So we have found so far that the original amount we owed, P of 0, was 10,000. The amount we owed after 1 year was 10,000 times 1 plus 0.06, which is 10,600. And the amount we owed after 2 years, P of 2, is 10,000 times 1 plus 0.06 squared, which comes to 11,236. Now, how much do we owe after 3 years? P of 3 is going to be P of 2, what we owed at the end of the second year, times 1 plus 0.06 again, which gives us 10,000 times 1 plus 0.06 squared, which is P of 2, times another factor of 1 plus 0.06, which gives us 10,000 times 1 plus 0.06 cubed. So P of 3 is 10,000 times 1 plus 0.06 cubed. And what do we expect is how much owed after 4 years? P of 4 is 10,000, the original amount we borrowed, times 1 plus 0.06 to the 4th power, because we'll pay that 6% interest each of the 4 years. And in general, the amount of money we owe after t years is P of t equals 10,000 times 1 plus 0.06 to the t. With this formula, it is easy to answer questions such as how much money is owed after 10 years, without having to do it 1 year at a time. We can compute P of 10 is 10,000 times 1 plus 0.06 to the 10th power, which comes to roughly $17,908.48. And suppose we graduate after 2.5 years, and interest accrued while we were in school. How much money is owed after 2.5 years? Well, we can compute P of 2.5 is 10,000 times 1 plus 0.06 to the 2.5, which comes to roughly $11,568.17. This question not only would have been tedious, but would have been very difficult to answer without finding our formula first. Because previously, we could only find the amount of interest in an entire year, not half a year.